Hi, in this video, I want to share with you some API key authentication best practices. We have spent a lot of time at Zuplo designing our implementation of an API key authentication service, which is part of our gateway. And in doing so, we also spent a lot of time researching how others had gone about solving these problems. And so what we've done is we've collated some of the things that we think are best practices. If you're going to implement API keys yourself, these are some of the things you should really think about, and these are the decisions and some of the trade-offs that you're going to need to make. The first question, though, is like, why would you use API keys? Why not? We've written about this on our blog in the past, and there's a couple of reasons why API keys are attractive. The main thing you're comparing that against is probably JWT tokens, JWT and OAuth. And I think OAuth, or we think rather, OAuth and JWT are a great choice, especially if your API is doing something on behalf of an individual user. So you remember back in the day when everyone was building their own Twitter apps, that was on behalf of an individual user that was calling the Twitter API. OAuth is great for that. In some cases, you have GitHub APIs that actually support, they have API key APIs and they have APIs that use JWT tokens. The APIs that use JWT tokens are the ones that are doing something on behalf of a user. The ones that use API keys are the ones that are doing something on behalf of a sort of a system or an organization or a backend that's not a real human being. And so their OAuth typically makes less sense. I think actually what GitHub decided to do is they're an excellent example of how we think about it, and I'll explain some reasons for that. If you look at the world's best API first companies in the world, the people that come to mind are people like Stripe, like Twilio, SendGrid. I really like Airtable. They all have one thing in common, and that is they all use API keys. Once again, their APIs are not typically doing something on behalf of an individual user. They're doing something on behalf of an organization. So when we call the Stripe APIs, we do so as Zuplo, not as Josh Twist. And I think that makes API keys a great fit. And some of the reasons for that are, well, one, they're much easier for engineers to use. And with engineering and making developer experience work, it's really about avoiding death by 1,000 cuts. The best experiences, they might seem like trivially better, but that adds up to just everything being easier. So some examples of things that are easy with API keys. I don't have to think about complicated OAuth flows. I just get my API key, I stick it on the header, and I send it. In testing the API, that really makes everything much easier. A curl is like one curl command. It's not client ID, client secret, building this complex OAuth dance of redirects and then pulling my JWT token out of something and then sending it on API call. That's actually quite painful. It's important when you're doing on behalf of a user, but if you're not, it's questionable in terms of value. And this is why these great companies use API keys. They really care about how easy it is for engineers to be successful using their API. So they spend a lot of time reducing or focusing on optimizing that time to first call. How long does it take to invoke this API so that they feel successful and they're making progress? One of the biggest complaints against API keys is that it's not a standard, and I think that's true. The nice thing about JWT tokens is that they're fairly standardized at this point, and you just go and follow the protocol and it's well written. That's one of the reasons we've put this guide together, though. I don't think you should discount API keys. If it's good enough for Stripe, if it's good enough for Twilio, it's good enough for you. The other argument against API keys is security. This is also pretty debatable. There's pros and cons here, actually. And again, if the likes of Stripe and so on, where it gives you sort of access to the farmhouse and the barn through their API keys, if they trust it, then I think you can as well. And there's some actual benefits to API keys in terms of security. JWT tokens, they're JSON packets. That's what the J stands for. They're JSON data, I think base 64 encoded and stored in a signed token. That means anybody, like you can take any JWT in the world. Actually, if you go to jwt.io, you can take any JWT and you will see that you can see the contents of that JWT token, even if you don't have the secret that it was signed with. It's kind of public information. That might contain information about your claim structure. It might give people some better understanding of how your system works and potentially use that to form some kind of attack. So there's some value in being just an opaque string. Like an API key is just a GUID typically, or some kind of like high entropy random string. And that's valuable because only you know what it means. Only you, the system owner, when you go and match that to a record on your database, have any sense of what is actually inside of this key. The other thing that's important is that API keys can be self-serve managed. So that means me as a developer, I can go to my Stripe dashboard, I can get my key, that's nice, but I can also roll it. So if something happens with that key, I can go in and say, oops, I leaked this, I accidentally recorded it in a video like this one I'm making now. You know, we've all done that when we're making demo videos. I can go in and I can roll that key instantly. It's revoked, it's gone. That's harder to do with JOTs. JOTs have an expiry, and unless you pick a very short expiry, which then actually makes the development workflow even more complicated because the refresh token flow comes into play, and you have to think about that whole dance. The idea that I can revoke a key, it's much more powerful, whereas with a JOT token, to revoke that's a very involved process. Often what will happen is you'd have to revoke the whole client, the whole space of people using those JOT tokens, which would impact all of your tenants. So that's pretty suboptimal as well. So there's actually a number of feathers in the cap of API keys and why they're arguably in some ways more secure. We feel super comfortable using them. We recommend them. And actually there's been advances recently, and we took part in this with the GitHub scanning program. So the format of our keys, which I'll talk about as we go into the best practices of API keys, ours are formatted such that GitHub can recognize them, and if they get checked into source control by accident, they notify us, and then we can notify you as a customer. Anyone can participate in that. You can write your own secret scanning code. You have to do it in sort of the way we've done it. You have to go through an onboarding flow and a program with GitHub. If you use Zuplo, we take care of all that for you, but you can absolutely do that yourself, and it's one of the best practices we'll talk about in a minute. When coming to decide about API keys, there's one major decision that you need to make in terms of like how are you going to design this. And it's whether you want the keys to be what we call retrievable or irretrievable. And I'm assuming as an engineer, you've probably seen both kinds of these. An example of an irretrievable key is I go to some dashboard, some developer portal, and I create my key. My key is shown to me. I can copy it out of that product and put it ideally into some kind of vault. Or what some people do is put it in Notepad or TextEdit, which is bad. And that's the last time I'm going to see that key in that dashboard. Like immediately once I go away from that screen, that key is irretrievable. And the reason they've done that is because they don't want to store the key even. So if their database is compromised, then someone will only be looking at typically at sort of hashes of the stored key, and those hashes are one way, so they can't be reversed, so no one else can get the key out of the system. Businesses that do this are Stripe, Amazon, AWS, people who tend to be a little bit more on the secure, sensitive side of the domain, payments. Amazon AWS is your whole cloud infrastructure. They tend to use irretrievable keys. There's lots of examples that don't, Twilio, Airtable, Rapid API. They use retrievable keys. And what that means is I can go back at any time and get my API key without having to revoke the old one. I can just go in, see what it looks like, copy it away. I think there's actually a bit more to this trade-off than just like one is secure and one isn't. And that is one thing to bear in mind is that if you have irretrievable keys, people have to copy them somewhere immediately. If your customers are a disciplined, well-behaved audience that are going to do the right thing and put that in a secure, encrypted vault, then this is good practice. If they might not be, then it's actually pretty risky because what that customer is probably going to do is stick it in Notepad or TextEdit on their machine, which is a very unsafe place for a key to be. They might even email it to themselves. This happens really. In fact, I'll put my hand up. I've been guilty of this. When I've deemed the API not to be crazy sensitive to me, I absolutely do this kind of thing. In those cases, I actually think retrievable is a better option because now I don't make that mistake of pasting that key. I know I can go back to the dashboard and get it. This is your decision to make. If you feel you fall on the higher bar of the security spectrum and your customers are going to be sensible and going to put that in a vault, then go with irretrievable. if you think the use case is like a little bit less sensitive, or your users are, perhaps like hobbyists at weekends who don't have access to a vault, then you might want to go with Retrievable, because actually that will be more secure, because they're not going to put the key in somewhere that they shouldn't, or email it to themselves, or send it over Facebook Messenger or something. So that's one of the biggest decisions to make when it comes to API keys. That's your call. I think I've explained the trade-offs as we see them. In Zuplo, our default behavior is retrievable for the reasons we've outlined. So you would get that for free if you use Zuplo as well. Let's talk about best practices. So the first best practice we've kind of covered when we've talked about retrievable or irretrievable, and make your decision and do that. But then the second is that you need to support a rolling transition period. So all API keys should be revocable. Actually, that's almost an implicit best practice. If you're going to go with API keys, you have to design your system such that a key can be revoked. To not have that would be just glaringly insecure and unacceptable for any system. What you do need to support is you need to support when the key's revoked, that the customer can set some kind of rolling transition period. And what that means is, let's imagine they go into your dashboard and they decide they want to roll the key. What's going to happen is if you instantly revoke that key, all of the systems that have that key logged into them or entered into them are going to fail. And so that's probably bad, unless this is a like Sev0 supercritical situation. And what most people do, like, I'll show an example of Stripe here, where when you roll an API key, you get to set what is the expiration date of the old key. You get to say, this should expire in like 5 minutes. That probably gives you time to take the new key, cut and paste it, and stick it into all the systems that have a dependency on it. So the key things there is that you support revocation and you support a rolling transition period. Another thing that's important is that you show the creation date of the key in your UI. This is how people know, has this key been rolled? When was it last updated? A lot of people want to roll their keys on some sort of cyclic basis. Like I might roll it every 6 months just to feel good and healthy about how often I'm sort of pruning the tree and keeping things fresh. And it's hard to do that if you don't show the date the key was created. If like Zuplo, actually, which I'm showing an example of here on screen, we allow people to create multiple keys so they can manage their own revocation. You can create a new key and then delete the old one on your own time. It's really important to show when it was created so people can disambiguate between the keys. The next best practice, number 4 here, is checksum validation. So we do this, and this was actually guidance that came out of GitHub's best practices on API keys for their GitHub Secret Scanning program that I'll talk about in a second. And what that means is that at the end of the key, we actually put a checksum. And that allows us to when secret scanning is taking place, we can verify that this key looks like it was sort of at least somewhat legitimately created. It's not proof, like anyone could create a checksum. But it allows us to do sort of a very quick false positive. Is this just a random string here that we're playing with? Is it just some random GUID, or has someone at least gone to the length of creating a checksum out of this? This is also useful on GitHub Secret Scanning, as I'll talk about in a second. You could go further with this. You could actually make that checksum a signed hash, similar to a JOT token. We don't do this today on Zuplo, where we talk about it, where I think if we get a customer interested in it, we'd add it as an option potentially. And with the signed hash, that means that the signing authority can have absolute confidence when presented with a key that it was generated by their system. So this allows, in the case of an API, it allows you to reject invalid keys. Now, you still have to check for revocation, but it allows you to reject like just completely invalid keys without doing a database check, without calling any subservices. You can just check that. You can just create a copy of that signed hash, see if it matches up, and if it doesn't, reject it. That's how JOT tokens work. So it's highly performant. It's a common approach, and it would be absolutely fine to do so. It adds a little bit of, a little bit more work, a little bit more complexity. So we don't do it for that reason at this time, but it can provide additional protection and potentially additional performance if you get a lot of fake API keys sent to your service. Most people don't deal with that a ton. So it's, it might be premature optimization to do that until you see that being an issue. Best practice number 5, support secret scanning. So API keys, I think are defensibly a secure solution, but we all make mistakes. And one of the downsides of these keys is they can sometimes, if you don't put them in your environment file, they should go into your sort of environment variables and not into source code. They could get checked into a source control repo. Fortunately, GitHub has a secret scanning program. You can run this on your own repos without getting their permission. Just search for this. I'll provide some links in the video comments. You can also enter the GitHub Secret Scanning program, and what that does is you give them information about the structure of your key, like essentially a regular expression that matches your key, and that will go into GitHub, and they will scan source code and look for matches. And if they find a match, they'll notify you and say, hey, we found this thing that looks like a key in a public repo. It will also run on private repos that people have opted into. And we do this at Zuplo. So if someone's using a Zuplo API key and it gets checked into a public source repo or a private one that's opted in, we will get notified. We in turn notify that customer. We automatically revoke the key, and depending on their settings, we'll notify their customer as well. Really important thing to do to make sure that API keys are secure. And we really, I think what we're trying to do here with these best practices is sort of, these are what we think are becoming the standards of API keys, or what should become the standard. So it's exciting to try and start that conversation. But this is a must-do for your API key. And that's why you want to think about the format. For us, we start with ZPKA_, and then if we get a key reported to us by GitHub, before we do anything about it, we quickly check the checksum to make sure it's real and not just an unlucky random string that looked like a Zuplo key. And if it is, then we'll go and search our database and find the key and find the customer and do the notification. Best practice number 6. So on an API, you're going to be receiving the API key typically as a header. I think people are pretty open. That can be an authorization header with a bearer and the API key. It can be an API-key header. That's up to you. I think that's pretty flexible at this point. But what that means is your API, the first thing it's probably going to do is do a check. And typically your keys are stored in some kind of secure storage, so, hopefully encrypted or as a one-way hash if you're using Irretrievable. And that means a database call of some kind. You probably don't want to do that on every single read. It's going to add latency to your API. It's going to add load to your database. So you probably want some read-through caching strategy on the API key check. So that means every time a key comes in, you go and check it, you pull out the metadata associated with that, and then you might want to store that in an in-memory cache in process with your API, if that's how you're building it. With Zuplo, we have a much more complex system because we're a distributed gateway. We run at the edge at over 200 data centers around the world, and highly scalable on a serverless architecture. So what we do is we actually store these in a secure cache at the data center level. That means that we can do the API key checks extremely high performance and are reading quite local to where that machine is, even in a distributed manner. Now we have a timeout on those, so it means every 60 seconds or so, we have to go back to the database and get the key. We've actually designed that to be so high performance, we do that asynchronously. So we go and make the call. We almost never block an API on an actual database call once the system's warmed up. So you can look at strategies like this to reduce the latency and reduce the impact of API key checks. Best practice number 7. Hide the keys until needed. We live in an age where everybody has a high quality, high resolution camera in their pocket, and people are recording things all the time. And so if someone goes to your dashboard and the API key is displayed, that could easily be captured by somebody with a quick photograph or someone recording a video, and they now have your API key. So you really want to be pretty sensitive about how you show that. And I give an example here of Superbase, who they have a secret that they hide until you press the reveal button. I think you can go even better. What we do in Zuplo is we have a reveal button, but we also have a copy button. So if all you want to do is copy the key to the clipboard, you don't even need to reveal it. Just click the copy button, we'll put it on your clipboard, and then you can paste it in, and hopefully the thing you're pasting it into has a password mask on it. And your API key was never seen on screen by anybody. So that's what we think is like best practice. Actually, there is like hide the keys. Ideally, provide a copy button so they never need to be revealed. But obviously, it's useful to reveal it to people in some cases in case it needs to be read out or inspected visually. Best practice number 8. This is a real attention to detail thing. When formatting your API keys, it might be tempting to put dot separators in or dash separators. That's what you get with a GUID, for example. We'd recommend against that. Change it. Change it to be underscores so that it's in snake case. Why? Because if someone needs to cut and paste that key, you can just double click anywhere on the key and it will select the whole thing. If you break that key up with a period or with dashes, you can only select that section and it makes copying and pasting the key a pain in the butt. So let's be thoughtful. Let's pay it forward and be nice to future developers who just want to cut and paste this thing into their clipboard. And so let's use snake case as the format for API keys. And then finally, best practice number 9. Consider labeling your keys. Stripe do this. We do this at Zuplo. And that means give your keys some kind of name at the beginning that is fixed. So in the case of Stripe, they have SK Live, which tells you this is their secret key. So it's very sensitive. And the live tells you that it's a live key. It's real. It's not a test key. If you, they also have keys called PK test, and PK is a publishable key. That means this is shareable. It's not that sensitive. And the test obviously tells you it's a test key and not a live key. So why is that useful? Well, it's useful for a couple of reasons. One is someone in support, so working on your support team, or if you're helping someone debug an issue, you can very easily ask them, can you tell me how that key starts? Does it start with SK Live or SK Test? And if they've accidentally put a test key into production, then you know that's probably where they're going wrong. If they've actually put the SK key in something that expected the PK key, again, it can really, really help with debugging. Also, if the key is discovered in GitHub Secret Scanning, you instantly know, well, if it's the publishable key, that's fine. You know, with the publishable key is publishable by design. It can go on a website. That's kind of what it's designed to do. If it's the secret key, then that's more like panic stations. Someone has published their sort of keys to the house here, and we should really help them. So it doesn't cost anything to do this. It's a really nice, neat little practice, and we do it at Zuplo, and we found it useful. So essentially, that is what we think are 9 best practices if you're going to design your own API key implementation. So I'm going to walk you through sort of a canonical check now of what that might look like if you actually go and implement that. So the request comes in to your server, the incoming request. You check, first of all, is the API key present and is it in the correct format? If it is, the next thing to check is the checksum valid? That's very cheap, so we know if we're just getting garbage API keys, we can just reject that with a 401 right away. Very fast, microseconds of compute time. The next stage is to check whether we have, assuming the checksum was valid, is to check whether we have a valid key in the cache. If we do, and we're happy, you know, that we set a deliberate cache expiry on this, then we can just let the request proceed. So actually at this point, move on to the business logic or whatever, and you can be happy that the API key is valid and use the metadata associated with that key. But if there is no key in the cache, then it's time to go and call your API key store. So in that case, you'll be calling the database where your keys are stored, hopefully either encrypted if it's retrievable. So that'll be like symmetric or asymmetric encryption that allows me to reverse the encryption and get the original key value back. Or if you're irretrievable, then that really should be a one-way hash, a fast one-way hash like SHA-256. You don't really want to do bcrypt here because it'll be too slow and will add latency to your API. Once you call that API key store, if you find the key to be valid, then you should store it in the cache. If you find the key to be invalid, you probably want to store it in the cache as a false key, as like something to be rejected. Because if a person keeps hitting you with that key, you want to be able to just 401 them very fast and sort of say, no, thank you, we're good. Also, you probably still want to do rate limiting on a per user basis, even if the key is invalid. Even if it's not a recognized user, you know, your rate limits are going to recognize that they're not an actual user and going to kick in. One thing about the cache, it does obviously have a bit of a trade-off though, actually, as you think about it, as we talk about the cache. One downside is if you cache these keys in memory, it does slow down revocation. That's why we'd recommend not putting them in cache for too long, so that if a key needs to be revoked, the key is only live for like maybe 60 seconds or something like that. You can have strategies to proactively go and flush the cache or flush that key from the cache. It just gets a little bit more complicated. So, we have some techniques like that at Zuplo. But if you're building this yourself, you might not want to go quite that far, and it's probably fine to have a key live for an additional 60 seconds. If it's totally not fine, then you're probably just going to have to turn off the cache. You need a kill switch on it if that's something that you couldn't live with. But yeah, that's the flow through a kind of canonical API key implementation and some of the best practices that we've learned in designing our own API key solution and looking at how other businesses, what we think are the best API first businesses, have implemented it. So good luck, have fun. If you do decide you'd like help with this, then of course Zuplo can add this to your API pretty easily, and you might want to give us a try. But otherwise, thanks very much.